Now, what about the effect of product concentration? Again, here we have data for a system which is in equilibrium. In a first situation, there's a stress applied which causes equilibrium to be disturbed for a while, and then it reaches a new equilibrium. What's the original equilibrium constant? What stress is applied and what effect does that have? And what is the new equilibrium constant, and what do you notice? The Kc value for this reaction is 50. Again, that shows that the reaction, when it's in equilibrium, lies to the right, because 50 is a large number for a ratio. It doesn't lie as much to the right as in the previous equation that we spoke about where Kc value was 64, because those use different chemicals to here. But it does lie significantly to the right, and that can also be seen by the Hi concentration, which is also raised to the power 2 in the Kc calculation because of the coefficient in the balanced equation. So the Hi concentration raised to the power 2 is significantly larger than the concentrations of the reactants. So we see that this equilibrium state lies to the right, and we notice that even though we apply a stress, afterwards the new equilibrium that is attained lies just as much to the right. Kc is also 50. Now, what is the stress that is introduced? It is an increase in concentration of Hi, in other words, an increase in concentration of the products. And what effect does this have? It disturbs the equilibrium for a while, shifting the reaction to the left, favoring the reverse reaction, in other words. It does that for a while, and that tends to counteract that increase in Hi that was brought about by using up some of that introduced Hi, hydrogen iodide. And then after a while a new equilibrium is established, and this has the same Kc value as before the disturbance. So although the concentration of the reactants and products before and after the disturbance in the new and original equilibria are not the same as one another, their ratios raised to the coefficient powers is the same before and after the disturbance. So again, we see the system responding to the stress in such a way so as to counteract the effect of that stress. Alright, so we've just seen the effect of increasing the concentration of products. What about if we had decreased the concentration of products? What would that have caused? Again, the system would respond such that it would tend to counteract the stress, and in this case the stress is making the product concentration lower, and so the system would try to increase the product concentration by favoring the forward reaction, shifting the reaction to the right for a while until a new equilibrium would be established, which would have the same Kc as the original equilibrium would have had.